All right, Ozarka here. This is going to be a video all about solving linear equations. And just kind of, if you look at these notes right here, just kind of want to take a step out before I start. This first part, again, like I just said, is solving linear equations. We're going to go over some guidelines that I would follow when solving these. We'll have some examples. But besides the linear equation, just straight up math problems, we also have these application problems as well that we're going to go through with a couple examples from that. So that's kind of a breakdown of what this video is basically going to entail. Let's get started here. All right, so I'm going to zoom in here. Section 1, linear equation. So the objectives for this particular section, it says right there, recognize a single variable equation as linear and solve it. And there could be 0, 1, or infinitely many solutions. So we're going to kind of actually touch upon every single type of the amount of solutions there are. So you're going to have some that have 0 solutions, 1 solution, and infinitely many solutions. We're going to translate the problem situation into an equation and solve. So that's where these application problems come into play, the ones that I kind of just talked about a second ago. So we're going to be translating those basically from English to math, because math will allow us to actually be able to solve those equations. So that translation piece is going to be super important for this section. All right, so before we start solving linear equations, let's actually talk about what a linear equation is. So it says right here, a linear equation, highlight this here. A linear equation is an equation in which a variable appears only with the exponent of 1 and not in the denominator of a fraction nor in a radical. So that's a lot of words, and sometimes it's, rather than like, you know, kind of defining this with English words, it's easier to just kind of define it with math words. And it's any equation that you can basically be written in the form of what I just highlighted in yellow there, where it's the ax plus b. So basically there's something with an x in it, and you know, one of the terms has an x in it, and you could be multiplied by some value, and then there's a constant as well, and sometimes that constant is 0, but 0 is still a constant, and it can be set equal to 0 if you wanted. So anytime you have an equation basically that has an x in it and no other real variables with any other exponents besides 1, it's basically going to be a linear equation. And what we're going to be doing in this section, again, is solving these linear equations. You're basically going to be isolating that x, getting the x by itself, so that the final equation will be x equals whatever the answer is, if there is an answer. And it is important to understand that if there is an answer, there's going to be one of them. Otherwise, there might be infinitely many solutions or no solutions. And again, we're going to talk about that as we go through these problems. All right, so this first section right here, solving linear equations. To solve an equation means to find all replacements for the variable that make the equation true. So you're finding the value of x that will make the equation true. We typically solve linear equations by constructing a sequence of simpler equivalent equations. At some point in the process, the solution becomes obvious. So we're going to start with this example first. It's kind of all drawn out a little bit, but I'm going to just kind of do a play-by-play for each step on this, so it kind of makes a little bit more sense. Let's zoom in a little bit here. So the original equation, what it starts off with is just this part right here. It says solve for x for that equation. First thing that you'll notice that was done here is the 3 is distributed here. So actually, let me highlight this to make it a little bit easier. So this blue highlighted right here is going to line up with this blue highlighted right there. Everything else stays the same. So it has the plus x, it has the equals negative x plus 7 as well. So everything is kind of the same. The next step is combining like terms. So we have the x here and the x here, and that's basically going to get us this 4x right there. The minus 3 just drops down. The negative x plus 7 just drops down as well. So we're kind of doing this problem solving bit by bit, just so it makes more sense. There's an x on the left and an x on the right. And again, the whole goal of this is to get x by itself. You want to solve for x, isolate the x. So what we're going to do is we're going to add x to both sides. So that's basically the next step here. So we're going to add x to both sides. I'm going to make that a little better here. Let's do x plus like that. And basically that negative x and plus x here cancels. And then on the left side, it combines to get this 5x here. So now you have 5x minus 3 is equal to 7. From there, we're going to add 3 to both sides to get rid of that minus 3. Because again, the whole goal is to isolate the x. We want to get x by itself. This is going to get rid of this 3 here, and then you're going to have a 7 plus 3, which gets you the 10 right here. The 5x just drops down right here. And the last step basically is to divide both sides by 5. Okay, because when you do that, this 5 and this 5 are going to cancel. Now the x is by itself, and then you have 10 divided by 5, which is equal to 2, and you end up with the final answer of x equals 2. Now, what this x equals 2 means that if you actually were to plug it in to the original equation, so if we were going to go all the way back to this original up here, if we plugged in 2 for the x here, 2 for the x here, and 2 for the x here, that equation should technically be correct. So let's actually try to work this out and see if it is true. And by the way, you can do this every single time to check your work to make sure that the equation does actually work. You're going to have a 3 times 1, which is just 3, plus this 2 right here, so plus 2, is equal to this right here is negative 2 plus 7 is 5. This does check out, so that means we definitely know that x equals 2 is the answer. Okay, so that's a bare bones example. It's kind of was just filling in the spots already. We kind of knew what the answer was. We are going to be doing some other examples that we're actually going to go step by step and solve. The steps aren't given right away. But that was just kind of a preloading your brain for what we're going to be doing in just a second. All right, this next part right here says general guidelines for solving linear equations. And it kind of follows what we just did, more or less. So it says remove parentheses if necessary by using distributive property. If you remember, that was the first step we did. To get that 3x minus 3 here, we distributed that 3. Next, it says combine like terms on each side of the equation. So again, the whole point is to isolate x. We want x by itself. So that means we have to combine all the x's, all the terms that have x, combine those on one side of the equation. And then everything else that's on that side, you basically just get rid of by doing the opposite. So it says use addition or subtraction to move all the variables to one side of the equation and all constants on the other. Okay, because again, we're trying to isolate those variables, whatever the variable is, so we can solve for it. If possible, we're going to use multiplication or division to get the equation in the form of x equals some constant. And we did that at the end when we divided both sides by 5 to get that x equals 2. If you remember, it was this step right here when we divided both sides by 5. Let me zoom out here. If possible, okay, we already talked about that. If the step above is not possible, your equation either has an identity, that means every number is a solution, so it's infinitely many solutions, or a contradiction where there's no number that's a solution. And again, we're going to go over all those different kinds of solutions in just a second with these other example problems. Okay, so that's that first page. Let's go to this page over here. It says important note, any step in the process above, so that process we just talked about, it could be helpful to clear the fractions by multiplying both sides of the equation by the lowest common denominator of all denominators. You're going to see me do that. A lot of times I just multiply by whatever the denominator is because then we don't have fractions anymore. People tend to hate fractions because it just kind of muddies up the process. So the easiest way to deal with fractions is just get rid of them right away. So that's actually what we're going to do. So for this problem, it says solve for x. So we have an x right here, but you'll notice there's all this other stuff with it. It's multiplied by 3. There's an adding of 11. There's a divided by 2. We need to get rid of everything there just to make x by itself. We want to isolate the x. So the first thing I'm going to do is get rid of that fraction like I kind of talked about before. I don't like fractions. I like it better when it's just a little bit more simplified. So the opposite of divided by 2, because that's what this line right here means. It means divided by 2. The opposite of that is multiply by 2. So I'm going to multiply both sides by 2 first. When I do that, this times 2 and divided by 2 are going to cancel. So now basically we don't have any more fractions. I'm going to rewrite this just to kind of clean it up a little bit. 2 times negative 2 is negative 4 is equal to 3x plus 11. Okay, so if you notice from the red step to the orange step, we no longer have a fraction, which is awesome. This problem's going to be a lot easier to solve. Now we want to get x by itself. That's still the goal. It's not by itself. There's still the 3 that's multiplied by it. There's still the plus 11. So what we're going to do is we're going to subtract 11 from both sides first. So once I do that, that gets rid of this 11. So you'll notice the side with the x on it, I'm actually going to put a division line right here just to make it, I'm actually going to kind of make a little boundary here to separate the sides of the equation. So if you notice the right side of the equation, it no longer has that 11 on it, it just has the 3x. I'm going to clean this up real quick now. So this is going to be negative 15. Is equal to 3x. So you end up with something like that. And just like that last example problem we had, put a line right here just to kind of divide this out. We're going to divide both sides by 3 here. And when we do that, it ends up causing that x to be isolated. So now it says x equals negative 15 divided by 3, which negative 15 divided by 3 is just negative 5. And we end up having the answer x equals negative 5. Now again, if you want to, I'm not going to probably be doing it in the video too much, but you can actually plug in this negative 5 into the x above here and see if that equation is still true. Okay, I'm going to kind of do it really just quickly in my head here. So negative 5 times 3 is negative 15, plus 11 is negative 4, divided by 2 is negative 2. So that does actually work out, but again, you can kind of check it on your own. For the sake of this video, otherwise it's going to be way longer if I just keep checking all of them. I'm just going to keep moving on. But again, it is good to be checking your work. All right, onward to the next problem. Looks like we have some distributive property here for number 2. That's the first thing I'm actually gonna be dealing with here. So first thing is I'm just gonna copy this left side down really quick. Distribute over here. So we end up with something like that. All right, from here, I'm going to combine all the v's on one side. So if you notice, I can kind of divide up this equation from the left side and the right side of the equal sign there. So there is, the smaller v is on the left, it's that negative 6 is smaller than 5. So what I'm actually gonna do is I'm going to add 6v to both sides. That way, I just don't have any negatives. It just makes it a little bit easier. You don't really have to do this. You can kind of pick and choose which side you want that v to be on. You'll get the same answer regardless, as long as you do the math right. But for the sake of this problem, I'm actually just going to move the v's all to the right. And while I'm here, actually, I'm going to also add 10 on both sides. So the right side is going to have all the v's, the left side is going to have all the non-v's or the constants. And if you notice, I try to color code everything on this so it makes more sense. I added 10 to one side, I have to add 10 to the other because of that equal sign. Equal rights in math. If you do something to one side, you equally have to do it to the other. Same thing with the orange there, it's the plus 6v on both sides. Everything has to match, everything has to be balanced. It's going to cancel this out. So now if you notice, on the right side, everything has a v in it, which is awesome. That's what we want. So now it's just going to be 11v on this side. And on the left side, it's going to be negative 11 like so. The last step is to get v by itself, I have to divide both sides by 11. So I'm going to do that really quick. It's going to cancel out these 11s here. So now v is by itself, and then we have v is equal to negative 1 as the final answer. So now if you plug in that negative 1 into the original equation, you would get 6 minus 21, which is negative 15. If you put the negative 1 on the right side, you're going to get negative 1 minus 2 is negative 3. Negative 3 times 5 is negative 15. So you would get negative 15 for both sides. So that does check out. Let's go on the next one. It looks like there's 2 distributive properties that we're going to have to use on this one. So this first one right here, negative 20x plus 20 plus 7x is equal to 3x plus 12. So I'm gonna put that line there to separate one side of the equal sign from the other side of the equal sign. So you end up with something like that. First thing I'm gonna do from here is I'm going to combine like terms on the left. So you're going to have 13x. So basically this and this is gonna be negative 13x there. I'm gonna have the plus 20 right here. And then this is equal to 3x plus 12. All right, it is easier to move the smaller one, so I'm going to add 13x to both sides. So I'm going to get rid of basically that negative 13x. So I'm basically getting rid of the smaller x term on the left side in this case, because it's the negative 13. And when we do that, this is going to cancel here. So now you only have a constant there, you have that 20. But we still have the 12 on the right side, so I'm actually going to subtract 12 on both sides as well. Make sure you do it to both sides equally. It's going to cancel this out. So now you're going to have 16x here and 8 here. From here, I'm going to divide both sides by 16. Kind of running out of room here. Divided by 16, divided by 16. It's going to cause these 16s to cancel here. And you're going to get x is equal to 1/2. All right. Next problem. Okay, so we have 2 fractions on this, essentially. So we have 2 fractions here. What I'm going to do is basically multiply both sides by both denominators. Okay, so there's an 8 denominator and a 10 denominator. I'm going to multiply both sides by those denominators right away. It basically just gets rid of any of the fractions, and then we can just solve it like we solved the last couple problems where they didn't have fractions. So first thing I'm going to do is multiply both sides by 8. So when I do that, I'm going to end up with 9x. So if I distribute this 8 here, that 8 is going to cancel with it. And then I'm going to distribute it to the 2 over here as well to get 16, or negative 16, I should say. And then over here, I'm going to have 88x over 10. So when you multiply fractions, you just multiply across. You're technically multiplying by 8 over 1. So 8 times 11 is 88, so it becomes 88x. Now from here, if you notice, we have one less fraction. That 9x over 8, that's gone. So we have one less fraction. Now what we're going to do is multiply both sides by 10. I'm going to put that line there to separate each side of the equal sign as well. So what I'm going to do is multiply both sides by 10. Now if you notice, when I am multiplying both sides by those denominators, I'm multiplying the entire side. So I'm putting it in parentheses. It's kind of like how I did it in parentheses with the red step above. It just makes it so you actually are forced to multiply every single term by that number. This is going to cancel here, so you're just going to have 88x right there. Here we're going to distribute to that. It's going to be 90x. Distribute over here to that negative 16, and it's going to be negative 160. Okay, from here I'm going to, let's see here. I mean, there's x's on the right, so what we can do is just subtract that 90x on both sides. I mean, you could have subtracted 88x, but then you'd have to move the 160 as well. It doesn't matter. You get the same answer either way. It's just personal preference. All right. From here, we're going to end up with, so I'm going to kind of rewrite this over here. Negative 160 on the left is equal to negative 2x. Okay, from here, there's those negatives. I'm just going to flip the sign on both. So it's basically like multiplying both sides by negative 1 or dividing both sides by negative 1. It gets rid of that negative. It's a little bit easier to kind of work through. Divide both sides by 2. And you end up with 160 divided by 2. X is equal to 80. Okay. And again, make sure you are checking it. I'm not going to do that for the sake of brevity, so this video is not too long. But again, you're going to want to check your work on this, but that is the answer. Okay, 5 and 6, if you notice, have 3 fractions. So we're going to be repeating that same process that we did before. We're just going to be multiplying all those fractions away. It is a good idea to multiply, you know, sometimes it's better to multiply by the biggest denominator first, because sometimes it gets rid of other denominators. It didn't really matter so much with the last one, but this one, it's going to matter a little bit more. So what I'm going to do first is multiply both sides by 8, because that is the biggest denominator here. Something like that. And again, I'm going to put that line right there. All right, distribute here first, and you're going to have negative y. Distribute over here, you're going to have the 8 and the 4 are going to cancel to be 2, so you're just going to have basically minus 10 there, is equal to negative 8/3. So that 8 basically took care of that 4 denominator. Okay, and if you wanted, you could have multiplied 8 by 5 to get 40. 40 divided by 4 is 10, so you end up with the same answer either way. From here, we still have another fraction, so we're going to multiply both sides by its denominator, which is 3. And you're going to have negative 3y minus 30 is equal to, so this cancels here, negative 8. Okay, we're going to add 30 to both sides to cancel out that minus 30, and you'll be left with negative 3y is equal to 22. Divide both sides by negative 3. Cancel, cancel. Y is equal to negative 22 over 3. And you have your answer. Again, make sure you check it. It is also important to point out here, if you're not doing these by yourself, and you're just kind of following along with me, that's great, but eventually you are going to want to kind of cut the cord and be able to do these on your own. So what I advise doing is like maybe starting with problem number 6 here is like try to solve this entire problem by yourself. Okay, so I would pause the video right here, try to solve that problem, and then once you're done solving the problem, or if you're stuck on the problem, unpause the video and kind of see if you were correct or maybe if you did something wrong. Because the main thing is figuring out what you did wrong. A lot of people that are studying math, they're smart enough to kind of follow along with the teacher step by step, it makes sense. And it helps with the color coding of what I'm doing to follow along. And it makes you feel like you kind of understand it. But the main thing is you being able to do this on your own. Okay, because following along is one thing, but I don't want you blinking on a test because you're used to following along. You think this is easy, and then all of a sudden the real test comes and you end up not being able to do it. So I would pause here for number 6 and actually try to do number 6 on your own. Or if you want, you can just keep playing it, but I'm going to continue on right here. So I would pause, solve it, and then just hit play again and watch it. But anyway, either way, here we go. I'm going to put this line here to kind of separate that each side of the equal sign. And I have 3 fractions here. 2 of them are 5s for the denominator, and one of them is a 2. So what I'm going to do first is multiply both sides by 5, just to get rid of those 5 denominators first. It is important to note, too, that the reason why multiplying by those denominators cancels it out is because the denominator, that line means divided by. So it's like 1 divided by 5, like right here. It's 1 divided by 5. This is 5 divided by 2, negative 5 divided by 2. And the last one's 6 divided by 5. So since you're dividing, the opposite will get rid of it. That's why it always gets rid of these fractions here. Okay, 5 times 7v is 35v minus 1. So I'm going to distribute this to each of those, and you end up with a 1 there. I'm going to do the same thing on the left side as well. Multiply by 5 on each of these. And you're going to end up with negative 25 over 2v minus 6, because the times 5 and divided by 5 cancel. And if you notice, since I multiplied both sides by 5, I got rid of the fractions that have the 5 in the denominator. So hopefully that makes sense. But we still have one more fraction. The denominator is 2, so I'm going to multiply both sides by 2. Kind of make my life a little bit easier. So you're going to have 70v minus 2 on the left, negative 25v minus 12 on the right. Okay, from here I'm going to add 25v to both sides. I'm going to add 2 on both sides as well. So basically, essentially what I did here is I got rid of the 2 here, and I got rid of the negative 25v there. So now you'll notice the left side has v's, the right side does not have v's, which is perfect because that's what we're trying to solve for. So you end up with 95v is equal to negative 10. Now, right away you can see that 95 and 10, they both have a multiple of 5 in them. So what I'm going to do just to kind of make my life a little bit easier is divide both sides by 5. Just to kind of make it a little easier. And you'd end up having 19v is equal to negative 2. So again, I just divided both sides by 5 because you can. You can end up doing this when you simplify the fraction as well. Either way, you're going to get the same answer. Then I'm going to divide both sides by 19. And you end up with the final answer of negative 2 over 19. Again, make sure you're checking your work on that by plugging it into the original. 7, we have 2 fractions. One has a denominator of 4, the other one has a denominator of 7. So to start with, I'm just going to multiply both sides by 7. The entire side is going to be multiplied by 7. So you're going to be left with 35 on the left. On the left side, when you distribute, you're going to have 21x plus 21 over 4 plus 5x minus 1, because the divided by 7 and times 7 are going to cancel. We still have a fraction with that 4, so we're going to multiply both sides by 4. Again, multiply the entire side, so you're going to notice a lot of parentheses being used on these steps. 4 times 35 is 140. Multiply 4 here, that 4 is going to cancel with that denominator. Multiply 4 by the 5x, you get 20x minus 4 for that last part when you distribute the 4. Okay, it looks like all the x's, the terms of x's are on the right side, so I'm going to combine those here. It's going to be 41x, because I did the 21x and the 20x to get 41x. The 21 minus 4, so basically I can cancel this out. 21 minus 4, that's just going to be a 17. But just to kind of make my life a little bit easier, I'm just going to subtract the 17 right away, save myself the step. Minus 17. Okay. Now what's going to happen here is this is going to cancel. And then we have the 140 minus 17, which is going to be 123. Okay, from here we're going to divide both sides by 41. And we have x is equal to 3 as the final answer, because that and that cancels. X is going to be by itself. X equals 3. All right, onward we go. We've got a couple distributive properties that we have to do on this one, but other than that, there's no fraction, so this one doesn't seem too bad. But we shall see. All right, first thing we're going to do is distribute the 2. Add the W, distribute the 3 now. It's something like that. All right, the 2W plus W is going to be 3W, so I'm going to combine that. 3W plus 4 is equal to 3W plus 6. Okay, this is where we hit kind of a roadblock. Okay, there's a 3W on both sides. Well, it doesn't matter which side we subtract the 3W from. Let's just say, well, we're going to do it from both sides anyway. Doesn't matter which W you're referencing though, because what ends up happening is you end up with a 4 is equal to 6. Now obviously 4 is not equal to 6. That is untrue. Whenever this happens where there's no more x's, everything cancels out, and the equation that's left over is not true, for example 4 is not equal to 6, the answer that you're going to want to write down is no solution. That means there is no such thing as an x value that you can use that would ever make the original equation true. Now I said x, really I should say w, because w is the equation or the variable that's used in this equation. But either way, if the variables cancel out, there's no more variables, and you're left with something like 4 equals 6 or 1 equals 7 or something like that, something that's not true, obviously 4 is not equal to 6, it would lead to a no solution. So make sure you're aware of that. Whenever this happens, make sure you write no solution. All right, so for this one, first thing we're going to do is put that line there to separate the equal signs. So you have the left side of the equal sign, right side of the equal sign. Then we're going to distribute that -6 here. So it's -6W minus 6 plus 8W is equal to 2W minus 6. Okay, from here, the -6W and 8W are going to cancel to 2W minus 6 is equal to 2W minus 6. Now, whenever this happens, because again, this is similar to the other one that we just did, if you subtract both sides by 2W, this cancels here, this cancels here, you're going to be left with -6 is equal to -6. Now, that is actually true. -6 is equal to -6. So whenever that happens, you're just going to say infinitely many solutions. This means it doesn't even matter what you put in for W, it's going to work. You can put 1, 2, pi, -1,000,000. It does not matter. Everything is going to work. From -infinity to +infinity, every number in between, they would all work for this problem. Okay. So that's basically the last solving linear equations problem that we're going to do. We're going to move on to that applications problem now. So these are still going to be linear equations, but they're going to be like word problems basically. They're going to be written in English. We're going to have to translate them to math. That way we can use the power of math to basically solve these problems. So there's a little blurb here. It says in mathematics there is a well-known, very broad four-step problem solving process. 1, understand the problem. So you want to understand what's going on. You want to paint a mental image of what you're looking at. Think about any variables that you can have for the specific values. If you need to sketch a table, sketch a diagram, sketch a graph, whatever it is, read and reread the problem. Make sure you understand it forwards and backwards. Make sure you understand what it's asking for and solving for that. Sometimes people will solve for something else and the problem's not even asking for that. And then breaking down what information is given. So step 1, understanding the problem. Understand the problem. Step 2, devise a plan. So translate the problem situation into an equation. So you want to translate, again, the English to a math, because once you translate it to math, then you can use math to solve it. Next, carry out the plan. So you're basically going to be solving that linear equation, just like we were doing those other ones previously. And then next, look back, give the complete answer, check your solution, make sure it actually matches with what we were looking for. Check your work. That's always the best last step to do in math. So here's some examples right here. It says write an algebraic equation that represents the following problem situation. 4 more than the quotient of a number and 6 is 9. So 4 more. So we're going to try to translate this into math. Now it just says write the equation, so we don't actually need to really solve it, but a lot of times we are going to have to solve it for number 11, for example. But let's move on with this here. So it says 4 more than the quotient of So 4 more than the quotient of a number and 6. So it's 4 more. So it's 4 more than whatever the quotient of a number. This number, I'm just going to say it's x and 6. So the quotient means divide. So whenever you see quotient, it means divide. So 4 more, here's the 4 more. The quotient of a number, the number in this case is x and 6. Quotient means divide, so it's x divided by 6. Is, well, to translate is from English to math is just equals. So we're just putting an equal sign there and then write 9. So that's basically the answer for number 10. 4 more than the quotient of a number and 6 is 9. And it just says write the equation so we don't actually have to solve. Now if you wanted to, obviously you could solve. It's really similar to the problems we were just doing, so it shouldn't be a problem. All right, number 11. When walking, Jose burns 96 calories per mile and Sarah burns 64 calories per mile. One day, the two of them walk a total of 7 miles. Let X represent the number of miles walked by Sarah. So we're looking for the number of, X is the number of miles walked by Sarah, but it says Sarah is burning 64 calories per mile. So there's a mile in there. It's just the per mile. So it's like divided by miles, calories divided by miles for that. So the first part, it says write an algebraic expression for the total number of calories burned by the two of them. Okay, so let's break this down here. First thing I'm going to do is write all the givens. I'm going to do that in black. So it says Jose and Sarah. Okay, Jose, it's 96 calories per mile. 64 calories per mile. Okay, they both walked a total of 7 miles, so that means that the distance of Jose plus the distance of Sarah is going to be equal to 7 miles. Now, the problem does say, though, that let X represent the number of miles walked by Sarah, so really it's going to be D sub J, so the distance of Jose plus X is equal to 7. So the problem just says to use X for whatever reason, so that's what we're going to do. Okay. Now, so far we do not have an algebraic expression for the total number of calories burned by the two of them. We have the rates of the calories, 96 calories per mile for Jose, 64 calories per mile for Sarah, but we need to actually figure out the total number of calories. So to figure out the total number of calories, we would have to be multiplying the Jose's rate of calorie burn and Sarah's rate of calorie burn by the miles, because it's calories per mile, so we're going to multiply by miles to get the total calories. So basically, I'm going to switch colors here. We would have something like this. We would have 96 calories per mile times the distance of Jose. So that distance, because it's in miles, will cancel out the miles over here, and you would have the total number of calories for Jose. We just don't know the distance for Jose. And then we're going to add this to the 64 calories from Sarah, and we're just going to multiply it by X because that's the distance for Sarah right there. Now, what's cool about this expression, if you notice there's two variables, there's that D sub J and the X. We can actually get this completely in one variable because we can solve for D sub J right here. In this case, we could just subtract X on both sides, and then we would have the D sub J is equal to 7 minus X. And the reason for that is because these X's cancel, so then you can see the D sub J is equal to 7 minus X. So I wrote it over to the left in orange right here. So what we can do is actually substitute that in, and you end up with 96 times 7 minus X plus 64X. So this is the answer for that first part. It's an algebraic expression. If you notice, there's no equal sign because it just asks for the expression, not an equation, for the total number of calories burned by the two. And there's only one variable X, which is awesome because then we're actually able to solve it. Now, if you kept the answer as the part in red, that's still accurate because it didn't say make sure there's only one variable being used. I kind of just went the extra step to kind of show you that. Okay, because that's what would be expected of you on like a quiz or a test, usually anyway. Okay, the next part, it says 2, together they burn a total of 505.6 calories. How far did each person walk? Well, we have the expression for the total number of calories, so all we need to do is make that expression an equation. So that's actually what I'm going to do. It's going to be 96 times 7 minus X plus 64X is equal to 505.6. So now all we have to do is solve that equation, and we end up with finding X, which is the number of miles that Sarah walked. Now, if we know the miles that Sarah walked, all we would have to do to figure out the distance that Jose walked is use this equation that we found before, where it's the d sub j equals 7 minus x. So if we solve for x and find Sarah's walking distance, then we automatically can use that to find Jose's walking distance. We just need to solve this thing right here. Okay, so first thing we're going to do is distribute. So if you notice, the numbers are a little bit bigger now, but that's completely okay. We're going to have 672 minus 96x plus 64 is equal to 505.6. And actually, I forgot to put the x here and the x here. I said it, but didn't actually write it down. That's embarrassing. All right, from here, we're going to simplify this out here. First thing is I'm going to subtract off the 672 because the x's are on the left side. I'm just going to keep them on the left side and move everything over to the other side. So this is going to cancel here, and you're going to be left with negative 32x is equal to negative 166.4. Okay, from here, we're going to divide both sides by negative 32. Cancel, cancel. X is going to be equal to, negative divided by a negative is going to be a positive, and you end up with 1.8. So this means that Sarah walked 1.8 miles. Well, Jose walked 7 minus whatever Sarah walked. So that means that, I'm going to write this over here. Sarah walked 1.1 miles. Jose, 7 minus that would be 5.2. He walked 5.2 miles. And this is how far did each person walk. It's kind of labeled right here, S and J, 1.8 miles and 5.2 miles. So that's basically a bunch of problems involving solving linear equations. Quite a number of them. Hopefully you're following along with the video pretty well. It is really important to develop this base of knowing how to solve equations, because while linear equations might be a little easy in the beginning, we're eventually going to be solving other types of equations, like quadratic equations, for example, where things are going to be a little bit more complicated. So it's good to have this firm base of what to do to solve linear equations. If you have any questions about anything in this video, let me know.